Today is August 8th, 2015. This is probably going to be the most interesting set of understandings that I have yet to learn. But I just want to go over some basics with people. That way, they can kind of get the whole transformation, metamorphosis process, other than the idea that, the star cools and dies, other than the idea that it loses mass and loses its diameter, it shrinks considerably, and other than the idea that the actual material undergoes phase transitions, which are obvious. But another way to attack the stellar evolution, planet formation process, they are the same thing, is to approach it from this giant word. It's Magnetohydrodynamics, or MHD for short. Now, originally, I was reading some articles concerning this. It's actually, Electromagnetohydrodynamics, but they wanted to shorten it out a little bit. But, obviously, electricity and electrical current are essential to magnetohydrodynamics. It just isn't magnetic fields by themselves. You have to have electrical current inducing the magnetic field. So you have your electro part, which is, obviously electricity, or I should say current. And then you have magnetic portion. You have fluid. Not liquid per se. I mean, it has it as liquid in lots of literature, but plasma is not a liquid, okay? And plasma is obviously magnetically driven fluid. So, but it's not liquid though. So I would rather say it's fluid motion. Liquid would only apply to, salt water and ionic solutions, things like that. So it's fluid, and then you have dynamics, meaning motion or movement. Meaning the fluid is moving because of the magnetic interaction, electrical interaction of the fluid. And there are four basic ways of looking at it. You have plasma, which is a completely ionized state of matter. And the degree of ionization is present in very young hot stars. Some stars are more ionized than others. They shine brighter. And you have liquid metals, such as liquid iron or liquid nickel, liquid chromium. That would be really strange. And, mercury at room temperature, where that's liquid, that conducts electricity. They use those in old school thermostats. I remember I took apart some thermostats at where I work just to see the little mercury capsule. You can shake it back and forth. It's really heavy stuff. And then you have salt water. That's very, very large abundance on the Earth. I mean, compared to the actual volume of the Earth, it's actually really thin, but, if anybody's ever been stranded in the middle of the Pacific Ocean, they'll see that there's a lot of salt water up there. And then you have electrolytes, meaning ionic salts, which are, similar to salt water. And you have strong acids and bases. Those also act as very, very effective electrolytes. They conduct electrical current very well. So yes, those have to do with MHD as well. So you have salt water, electrolytic solutions such as strong acids and bases, and you have liquid metals and plasma. Now, what I've noticed a lot in a lot of literature I've been reading, they ignore MHD in regards to the star's evolution. To them, it's just a mathematical model, and the star never loses mass, and it behaves just as they predict it to, which they don't actually have any valid predictions. So why it is that they consistently teach false information, I don't know. It confuses me. But you have a young hot star made of, plasma, and obviously the degree of ionization will determine how energetic it is, how bright it shines. When the plasma recombines, but eventually it cools and shrinks, and a lot of the magnetic fluid, the plasma, cools, and eventually a lot of the material settles out into this interior based off of the ionization energies of the plasma. So then you would have, liquid metal in the center of the star as it begins the process of core formation. Obviously, this is the time, it's the path the star takes. And as well as it's comprised of lots and lots of plasma, so it's still shining. This would be like a red dwarf right here, red dwarf. And then, you cool. And a lot of the material, when it combines, a lot of the elements that combine, as they cool from the ionized state, become gaseous matter. And the gaseous matter does fall inwards towards the center of the star and creates many different types of chemicals which are very electrolytic. Strong acids, strong bases exist in there. A lot of material that can conduct electricity very well are inside of, gas giant stars. And they're also under very high pressures, as well as you have liquid metal in there too. So you have a whole lot of crazy happening inside the evolving star. And then eventually, as the star cools and dies, it leaves its core in the center, and a lot of the material combines to make things like salt water, which is also an electrolytic solution, ionized solution, and a lot of the chemicals that haven't photoevaporated away from a hotter, younger host star means the internal regions will be less reducing, and then a lot of the oxygen will begin combining with the top portions of the star when it begins crust formation. And a lot of the higher heat capacity molecules will remain on top, and as they condense down, they obviously rain down, cool the crust, solidifying the crust, and from there you have it. It becomes the planet as we're familiar with it, the Earth. And then it just keeps on going, and all the more energetic material is photo-evaporated away from a hotter host star, and the Mercury-type objects just continues wandering the galaxy, orbiting other larger objects. So what we have here is the idea that we should apply this type of understanding. So you have really high energy magnetic fluid, loses energy, becomes lower energy magnetic fluid such as liquid metals, and the strength of the magnetic fields that are produced diminish considerably. So that means that the actual formation of things like sunspots or flaring will die down considerably because they can conduct less electrical energy, and their magnetic fields will shrink considerably as well. And then the fluids, which are in the internal regions, now I don't know exactly how the kind of convection happens inside the interior, but I do know that you have electrolytic solutions inside the interior. So if you want to predict how the solution is moving, you can look on the surface to see the differential convection. For instance, you have that kind of convection on the sun. I'm not going to do this perfectly, but obviously you have some bands moving faster than others. Maybe this one be slow, this one's fast, this one's slow, this one's fast. And you have that kind of differential convection inside the surface of it. As well, you have a lot of different types of strange structures, like a giant hexagon on Saturn. So you can literally use MHD to predict how and how that kind of hexagonal shape is formed. But what you would have to do is figure out where the magnetic fields are, how the fluid is moving, or where the fluid is, where the magnetic field is, and you can show how it's moving in the internal region. So you study the surface, you can go deeper into the star and find out how that material is flowing in its interior. As well, there's that approach, and then you go from the reverse. You study the Earth itself to determine how it is a fluid would have been moving in order to get to its current state. So there's that, which is obviously well beyond establishment, because they don't understand that, star evolution is planet formation itself. So they're kind of tied, with their hands behind their backs. They can't do anything. They have to always be politically correct. But my viewers, they understand that when you have an iron core in the center, some type of fluid motion involved a lot of liquid metal inside of the interiors of gas giants. So basically what I'm saying is there's a lot of information that can be had from this, and it's best to approach stellar evolution as well in the light of magnetic fluids in the way they move, because a lot of different things can be explained and used, such as we have eddy current braking. Here's one. Oh, this marker is dead. Let me use the other one. And I suggest looking this stuff up. You have eddy current braking, B-R-A-K-I, braking. That's important. That has a lot to do with the formation of sunspots and random types of things where the sunspot is breaking the flow of electrical, or breaking the motion of the fluids with electromagnetic energy. So that's very interesting. If you can explain sunspots in the light of eddy current braking, that would be incredible. A lot of the flares and really powerful events that store a lot of electric charge before they eject, well, that's clear. Those are electrolytic capacitors. Now, a capacitor is something that stores a lot of electric charge. And to think, if you have a giant object the size of the sun storing electric charge in random places on the surface, and the charge is magnetically confined, and then somehow that charge releases, yes, it's going to release a very, very large amount of electrical energy and a lot of charged particles. So they can function as electrolytic capacitors on the surface. I've yet to see a lot of the mainstream publications address the fact that charge can be stored and released in large amounts. And the rate at which electrical capacitance is diminished based off of whatever material is in there diminishes considerably as the star cools, because obviously the more energetic material moves towards the inner regions of the star as it collapses upon itself and differentiates the interior. So a lot of the old stars, they don't have the capacity to charge a lot of material, much less release the material. As well, the type of charge release happens in different ways, such as like the radiation belts around, evolved gas giants, which then also diminishes that.